Okay, thanks for the lovely introduction. Uh, Good morning, everyone, and it's great to be here in Taipei. Ni hao. Uh, yeah, I think Taipei is the only city where you can find faster Wi-Fi than some of these cloud providers uptime, right? So yeah, it's good to be here. So today, let's talk about our journey of how we built a security token service to serve like millions of requests with security and scalability. So my name is Suvin, and I'm senior software engineer at WSO2. And there's my email if you need to chat after the session about something. So yeah, in the next 25 to 30 minutes, we'll talk about what a security token service is and why we needed to build one of these on our own. Then why we chose to go with open source, and how we evaluated different open source projects to build our token service, along with the implementation and some of the challenges we faced and the things we resolved. And finally, I'll give you some pointers towards a framework on how you can evaluate open source projects for your enterprise needs. Okay, so let's start with what a security token service is. Right? So a security token service, is kind of a middleman in your organization for any kind of authorization and authentication. So if you have been to a nightclub, there's a bouncer outside, right? Everyone has to go to the bouncer, show your passport, IC, and verify your age, and then go in. So security token service, or an STS, is something like that. All requests in your enterprise should go through this one, and you have to authenticate and then authorize before performing any kind of thing in your network. Okay, so by using an STS, enterprises get different interesting usages. So the first one is your trust, your authentication, your authenticity is centralized, so that any service in your enterprise has to go through this one, and they don't have to build authentication and authorization on their own. So for your enterprise, you have one central service, and everyone will talk to it. You don't have to do it each and every time you need to authenticate or authorize something. Then you have interoperability. So let's say you are an organization with hundreds of microservices, and you need to authenticate and authorize them. So if different team builds different kinds of authentication and authorization systems, they might not be on the same page, right? So by having this centralized security token service, we can use standard protocols like OpenID Connect, OAuth2, so that your enterprise will follow all the standard procedures and protocols out there. Then scalability. So as far as your security token service concerns, it only has to authenticate and authorize, right? It doesn't have to know if you are using an API to order some food on Grab, or else if you are launching missiles to some country or anything. Your STS doesn't need to know that. It only has to authorize and authenticate your requests, and you can scale this independent of each other, so that if your authentication and authorization flows gets higher traffic, you only have to scale up one component. You don't have to do anything with your business logic. Right. With that, we'll discuss why we needed to build an STS on our own in our enterprise. So we had two problems. We already had an STS in our system, but it only supported two grants, like two types of authenticating, the client credentials grant and the token exchange grant. This is not enough for us. We need support for more grants. And then this STS was deployed in somewhere called the control plane. I'll explain this point a little bit later on. So speaking of support, the existing STS we had was part of our API management solution. So it's like the toy you get with your Happy Meal at McDonald's, right? You buy some food, but you get a toy as well. So our STS was that toy. We wanted an API management solution, and part of that API management product, we got an STS as well. So we went with it. Why not? But it was only supporting client credentials and token exchange grants. That was not enough for us. We needed to want some user-bound grants, like authorization code flow, refresh token flow, like that. So in our current product, if someone wants to use one of these user-bound flows, like authorization code flow, they had to bring in their own identity provider from outside, like Auth0, Ori, or something. Or else, we have an option where we initialize a default identity provider when someone logs into our platform. So this default IDP is also an external provider. The only difference is this identity management, access management product is also from our company. So we, by default, initialized it for them. So it's also an external identity provider. So for someone who just quickly signs up on our product, and if they wants to try out something quickly, this was a terrible experience, right? If they wanted to try out a user-bound flow, they had to sign up in another platform, configure your stuff, bring the configuration into our platform. It was too much of work. So we needed a better STS solution. Then the Happy Meal toy STS we had was deployed in the control plane. If you are familiar with cloud native best practices, there's a concept where you, in your organization, you should have a clear separation between your control plane and the data plane, right? So the control plane is the brain of your enterprise. It'll manage your infrastructure, it'll orchestrate stuff, it'll take decisions and all these things. And data plane is kind of like the muscle. It's the component that actually executes the decisions taken by the control plane, and it's the plane that deals with your data and does all the hard work. So in the cloud native best practices, you should have a clear separation in between these two. Okay, so if you take our existing architecture, every time a user authenticates with the user app or authenticates with another user app, it needs to go from data plane to the control plane, right? So this is the data plane, this is the control plane, this is the communication for the authentication and authorization. So this is adding an extra hop to our authorization and authentication flows. Right. So again, like I said, practices, you need to have a clear separation between these two, and your data plane needs to function independent of the control plane. Even if the control plane goes down, it shouldn't affect any of the user workloads. Starts to function as usual. So there's a test in cloud native world called chaos testing, where you take down the control plane and test that if your data plane is correctly working. So in our case, if we did a chaos test, it will actually be a chaos for all our customers, because the STS was in the control plane, and without that, you don't have any authorization. Nothing will work. Only 401 and 403 errors, right? Okay, and on a side note, we found out this issue on the worst day possible during a Black Friday period, where hundreds of users came to our platform, and then we figured this out. Right, so to summarize everything I said, we wanted a better STS in our enterprise that can handle various kinds of authentication grants, and that has to be in the data plane, not the control plane. And it should support tenancy, because our existing solution supported tenancy, so we didn't want to lose any of these existing features in the new one. And it should have the customizability that we can do anything with the implementation. So yeah, we are an enterprise. We have a paying product. So why open source? Why didn't we go to a vendor and then purchase something now, right? So we had a couple of options in taking this decision. The first one is to write everything from the scratch, one by one. But the problem with this one was the GTM rate, the go-to-market rate was too high. Like we had to do, and then we have to write code ourselves. We have to test them, and then we have to allocate multiple engineers, so many resources, and a lot of time into this. So as far as our customers concerned, these are not their problems, right? They are paying us money, and they are expecting a good service from us. So we needed something that we can go to the market fast and giving a better user experience. And then, is everything all right? Okay, perfect. It's okay. Okay, so like I said, we are using standard authentication and authorization protocols. Oh, it works. Okay, like OpenID Connect, OAuth2, things like that. So these are well-defined architectures and protocols. Like we didn't want to write the entire thing on our own because there are already implemented and tested stuff out there in the open source world. So why not using that? No, no worries. Okay. So I was saying these standards and protocols were already implemented and they were well tested. So we didn't want to reinvent the wheel and do everything from the scratch. And then the next option is to go purchase something, right? The first problem with that is vendor lock-in, right? When we purchase something outright from the box, our existing stuff has to be migrated to their platform. And once we do that migration, it's very difficult for us to move out again, because if we want to move out, that's another migration. And also, the licensing is not cheap. It's not like single user buying a product. This is an enterprise buying a license from another enterprise. So these are very expensive. And at the end, to cover our costs, we have to pass that cost down to our customers, right? That will increase our fees. And when things are expensive, people are finding alternatives, right? And then the integration difficulty. So in our enterprise, we have a way of already integrating stuff. If you want to use another product or a platform, we need to integrate our stuff with them. So for that, you often need to have these proprietary connectors or else protocols to communicate with this stuff. That's also a huge effort from our side to migrate everything to their connectors and stuff. And also, when we are buying a product outright, we don't have any customizability over them, right? We can't just go and ask them for features, ask them for customizations and things. It won't work. And our timeline, our product roadmap has to align with theirs as well. So it will not work for us. And also, like I said, enterprise support, getting support from the other platform is also going to cost us more, and at the end, it will become our product more expensive. So the benefits of using open source to mitigate and go across all these issues. So this code, the open source code, is well reviewed, right? It's open. Anyone can go and send a pull request. Anyone can open issues, report stuff, fix them. So these are well reviewed and validated by a diverse set of reviewers, right? So let's say I'm from Sri Lanka, and if I send some code, someone from the USA can review it. Someone from Taiwan can add a comment. See, all these people have different opinions, perspectives on this stuff. So this code is well reviewed. It works for most of the people in the world. And then transparency. You get access to the code, right? So you can go through the code, find out if there are any issues, also is there security vulnerabilities or performance hits and everything. It's very transparent. And then also customizability and integrations. You can write your own stuff, you can improve the code, but first you need to check the license as well. If it is like Apache 2 or something, you can take the code, modify it, and then use it. Simple as that. And also community support. So all of these well-defined projects, there's a good community around it. So for an example, if you're using Ruby, you can see a lot of Ruby people around COSCUP conference, right? So that's a community. If you have some problems, you can go talk to them. If that person doesn't answer your question, you can go find someone else. There's community support everywhere around the product. And also, no licensing fees. It's free, and no vendor lock-in as well. Okay, then we decided to move on with open source. But now the question is, who should we get? what product should we use? So we had 4 options for this. The first one is Ori's stack, and then Spring Authorization Server, the Foresight library, and Citadel. Ori, Spring Authorization Server, and Citadel are complete out-of-the-box solutions, but the Foresight library is kind of a library that we have to implement ourselves. So we took it out at that point because that's too much code for us to write, and the go-to-market will be high. So at the end, we left with these 3: Spring Authorization, Ori Hydra, and Citadel. So in Ori, if you have used, have you heard about Ori's authentication and authorization stack? So they have a couple of different products, decoupled products. You have to use Ori Hydra, Ori Keto, Ori Kratos, and some other stuff. So we didn't want to do that as well, because those are different products, different deployments, different infrastructure. We didn't want to do that. So Ori went out. And then Citadel. Citadel was looking very promising, but they only had limited support for these grant types. And token exchange, one of our main use cases, were covered, so that's why we went on that path. But dynamic client registration was not supported. That's one of our biggest use cases. So Citadel was out, and we were left with Spring Authorization Server. So before we move forward, this comparison was done about a year ago when we started building this. So right now, their product roadmaps can be changed, and this might be different. Yeah, so we went with Spring Authorization Server to build our enterprises STS. Now started the implementation phase. So we evaluated Spring Authorization Server very thoroughly, and we expected a very smooth go-to-market strategy, and we thought it was like very easy to do, like take the code, deploy it, and it will work. But no, there were like so many troubles along the way. Okay, the first one is, in our enterprise data plane, we didn't have any of these RDBMS solutions. Like we didn't have any relational database in our data plane. We only had a Redis instance. But Spring Authorization Server was built to work with Postgres. But Spring Authorization Server had an extension point where we could use that and implement our own storage layer. So what we did was, we created an extension on top of that, and we created this data layer to work with our Redis instance, and the problem was solved. Then in our enterprise, we had a separate user management and authorization services already deployed, right? So Spring Authorization Server has both of them built in. We wanted to make Spring Authorization work with our existing services for authorization and authentication. So we read a little bit about Spring's architecture and find out we can register these kind of providers. So what will happen is, when a flow goes through the user management phase, instead of talking to the Spring's default one, it will use the extension point we wrote. Same goes for authorization. When the authorization flow happens, instead of using the Spring's default one, it will talk to our service and do the authorization. So this is a beautiful thing about Spring Authorization. Every single thing is a building block, and you can customize anything in any way you want. Right, and then multi-tenancy. So in our product, we have support for tenancy, right? The tenancy was supporting organization environment separation. So for an example, Stark Industries organization, they have 2 environments, development and production. But Skunk Work organization, they have 3 environments, development, staging, and production. So we want to keep this same separation in our STS as well. So Spring Authorization Server doesn't support this at that time. So we created something called virtual STS. Inside the physical STS, we have small separated virtual STS, right? When someone creates an organization in our product, they will get the default environments will be created, and for each of these environments, we create one virtual STS, right? So this virtual STS will contain this organization and environment info, and then issuer's information, the issuer who issues you the JWT, and then signing keys for token signing. So these signing keys are independent of this organization environments. And then each of these virtual STS has its own kind of URL. So it goes like this: HTTPS, then organizations UUID dash, then the environment ID, then our STS domain.com, something like that. So this is how we implemented this virtual STS concept, right? So this is the default filter chain in Spring Boot. In here, before the request comes into Spring, we wrote this custom filter. We call it request context metadata filter. What it does is, if you remember this URL from the previous slide, this has the organization ID and the environment ID, right? So in this filter, we extracted out that organization and environment ID, and we put it into a thread local context. Then we let the request pass through. At the end, when the token is being issued, we need to sign that token, right, with that virtual STS's signing keys. At this point, we again talk to the thread local context, get the organization ID and the environment ID, look up the database, look up the Redis database, fetch the keys, sign the token, and then return it. So this is how we achieved multi-tenancy in our STS. So since Spring was not built for this kind of multi-tenancy, the JWK's URL and the well-known endpoint was not working for us. So we had to write our custom implementations to look up the thread local context and then return the response for both JWK's and well-known endpoint. So dynamic client registration, this is one of our major use cases. In the Spring's implementation, they only supported create and get, but we needed support for everything, all the CRUD operations, create, delete, update, and get. But there was no way for us to customize this when we were looking at the Spring's code. So we ended up writing our own custom DCR layer on top of Spring authorization so that we get all these capabilities. Okay. So yeah, that was how we solved a couple of implementation challenges we had. And then I'll give you some pointers as of how we evaluated these open source projects to go with Spring Authorization Server. So the rule is 50, 25, 25. The first 50% of your effort should go into the technical assessment, right? You need to check whether if the product you are evaluating has all the necessary features you want, right? You need to figure out what are the features that you need for your use case and if they're supported by the product. And then customization and flexibility should be at the maximum level, right? You don't know what requirements you are going to get in a couple of months of time in your organization. So you needed to have a flexible solution that is fully customizable, but you have to do it with a minimum effort and minimum time. Then integration complexity. If you are trying to replace an existing component in your organization with something new, you need to make sure that it is compatible with what you already have, right? It should be integratable with all the existing solutions in your enterprise. And of course, it goes without saying, security standards should be at the max, right? Okay, then the next 25% of your effort should go into the community's health. So what I mean by that is, you need to check the source code or GitHub repo to see how frequent commits are being sent, and then how diverse is the community, right? So if you take a product from a limited number of commits, so you can see this code is not being updated properly, right? All the commits are from like 2 months, 4 months ago, and no commits in the recent, and there are many open issues, no fix, and all the contributors are limited to students. So that won't work for an enterprise use case, right? You need to have contributors from all walks of life, developers, students, architects, all the people. And then issue response time. If someone opens an issue in the GitHub repo or the source control repo, you need to check how fast the maintainers respond to them. It doesn't always has to be a maintainer or some other contributor or someone, so that if you come across some issues in a later phase, you need to see how fast you get a response to fix that. And also you need to check whether how well they have documented their stuff, because without the documentation you're going to have to read through the code and understand stuff, right? It will take so much time. And also you need to check their roadmap. So in this current context, there are so many AI features coming up, right? So if your company needs those features, and if you have those AI features in your roadmap, you need to make sure the dependent stuff you are evaluating should also have that same support. So you need to check their roadmap and to see if that fits with your organization. So the last 25% of your time should go to operational considerations, deployment and complications, right? If there is a good product and if it consumes too much resources, then it's not profitable, right? In an enterprise, you should always focus on the profit. So, and then monitoring and debugging complexities. If your products doesn't have useful logs to figure out what went wrong, when something goes wrong, then you're going to end up in a very difficult situation, right? So you need to make sure that your the product you're evaluating has enough observability, and then debugging capabilities if you run across a problem in the future. And then licensing. Not all the open source products have the same open license, right? There are some partially open source license and things like that. So before you commit to a product, you need to make sure that this license permits you to do whatever the thing you want. So if you want to modify the code and sell it, you should be able to read the license and figure out if the original maintainers are letting you do that and all this stuff. So those are like operational stuff, not technical things. So yeah, this is what we follow to evaluate our STS. 50% for the technical assessment, 25 for the community, and another 25 for the operational health. So on that thought, this was our journey of using Spring Authorization Server, an open source project, to serve millions of tokens to so many users around the world. And like we did, may the open source be with you. Okay, if you have any questions, I'm very happy to answer. Yeah.
As you said, use the Redis to store your token, right? So how do you manage your token when the users became the more larger because you use a Redis?
Yeah, actually we are using Redis for all the persistence in the token service, but we don't store the token itself. The token is too big to store, and like you said, when there are so many users, the Redis will be exhausted. We only store the JTI, the ID. Yeah. Any more questions? Okay, then we can wind up. Thank you so much for coming. Have a good day. Thank you.